Hello scientific writers! In today's video we are going to talk about alternatives to the journal impact factor. Now in a previous video we talked about what the journal impact factor is, how it's calculated, and we also talked about how you should not use the journal impact factor alone. So today let's look at some other metrics and see how they compare to the journal impact factor. Hey guys, this is Brian from the Grants and Publications YouTube channel. So here we have a list of alternatives to the journal impact factor, which is by Clarivate Analytics. Clarivate has a few other metrics that they produce. One of them is called the 5-year impact factor, and that's just what it sounds like. Instead of calculating the journal impact factor over 2 years, it's calculated over 5 years. And then Clarivate also makes the eigenfactor score, the article influence score, and they just came out in this year with the journal citation indicator. They also have a cited half-life and an immediacy index. Their competitor, Elsevier, has some metrics including the cite score, Scimago journal rank, or SJR. They have the SNP, which is a source normalized impact by paper, and they have the H-index. Now remember, the H-index we talked about in a previous video. This is a metric that is used for individual researchers based on their publication number and citations to those publications. So I'll link to that video here, but we can also make an H-index for journals in a very similar way. And then Google Scholar has a couple of metrics that are called the H5 index and the H5 median. We'll also talk about the alt metric. In this video, we're not going to go into great detail on all of these, but we will define what they are, and then we'll do some comparisons. Now, in terms of definitions, I found this really helpful webpage on the Journal of Experimental Biology, where they list most of these metrics and have their definitions. And so let's just quickly go through some of these. The impact factor I already described in a previous video. I will link to it. Now the 5-year impact factor is basically the same thing as the 2-year impact factor, but it covers more years. The eigenfactor score is a measure of the journal's influence within the network of academic citations with a 5-year target window. The score considers the origins of the incoming journal citations to articles in that journal. Citations from highly ranked journals are weighted to make a larger contribution to the eigenfactor score. Scores are not influenced by journal self-citation. So this eigenfactor score gets around some of the ways that journal editors can distort their journal's impact factor by accepting only papers that cite that journal itself, for example. The article influence score measures article influence, but on an average per article basis. Cited half-life is a measure of how long the content is referred to after publication. The immediacy index is the average number of times that an article is cited in the same year that it is published. So how quickly do other articles start citing that one? The H-index is the number of articles in the journal that have received at least H citations. So if there are 100 articles that have received 100 citations, then the H-index is 100. And so like an individual researcher's H-index, this number is going to go up and up over time. So older, more established journals are clearly going to have a higher H-index than new, unestablished journals. The Scopus cite score is the average number of citations in a given year per paper published in the journal over the previous 3 years. So that's basically the same as the impact factor, only it's over 3 years. SJR is similar to the eigenfactor score. It ranks journals by their average prestige per article, whatever that means. And then the SNP is a source normalized impact per paper. This is the count per paper normalized according to its citation potential in the journal's field. The impact of a single citation will have a higher value in subject areas where citations are less likely and vice versa. So it sounds like there's some heavy data analysis going on to come up with the SNP. So the SNP is supposed to normalize between fields. In my previous video on journal impact factor, I mentioned that it's not necessarily accurate to compare journals in physics to journals in biology, for example. So the SNP score is supposed to make that field difference go away, and so that the journals in different fields can be directly compared. The two other indices that I mentioned that are not on that list are the Google metrics. So I'll show you how to find those Google metrics and how they are defined. If you go here into Google Scholar, what you do is go to the left side and click the three lines and then go down to metrics. And that's going to show you the top cited publications over the last 5 years. And it just shows you the top 10. So if we click View All, then you see that it expands the list to the top 100. And also you can go in and look at different categories. And each of those categories has subcategories. So you can really dig into that more deeply. But basically you see on this list the H5 index and the H5 median. And if we click on H5 index, it gives us the definition. H5 index is the H index for articles published in the last 5 complete years. It is the largest number H, such that H articles published in 2016 to 2020 have at least H citations each. And the H5 median is the median number of citations for the articles that make up its H5 index. So it's kind of removing that distribution problem that we talked about in the previous video by looking at the median number. The other one that I had on the list is the alt metric. So the alt metric measures the media impact of scientific publications. So let's look at this one example publication that is very highly ranked on the alt metric. It's in the top 5% of all research outputs scored by alt metric. If we look down on the left here, we see where this score is coming from. So mentions in news outlets, in blog, in policy source, tweets, Facebook pages, Wikipedia pages, Google+, Reddit, and videos. So it's taking into account news media and social media attention to the articles. So it's quite a bit different than looking only at citation rate. I will link to all of my sources in the description below. So we have talked about these other metrics that are alternatives to the journal impact factor. Let's take a look at how they compare. So this first slide that you see is a list of 15 journals that I selected that are ranked from very high impact factor down to moderate impact factor. And so what you're seeing here is the journal impact factor. So they range from 91 down to 3.2. Let's bring in the other metrics. So we see on this slide, we have not only the journal impact factor, but now we have the eigenfactor score, the H5 index, the H5 median, the site score, the SNP, and the SJR. Now they're still sorted in order from highest impact factor to lowest, and I've color coded these with the heat map. So you don't have to read all the numbers, just look at the colors. And you can see that there's not an exact relationship. So the highest ranked journal impact factor does not necessarily have the highest H index or H5 median, for example. And the eigenfactor score, you see it's all over the place. So what I would like to do next is convert this from journal impact factor to a ranking within these 15 journals. I've resorted the order of the journals by the mean of the ranking, which you see in the far right-hand column. Now, instead of the highest number being the best, now the lowest number is the best, because rank number 1 is the best. We still have New England Journal of Medicine on top, but the order has changed. You see that Nature was 6th on the journal impact factor. Now it's in 2nd position by averaging across all of these metrics. And now the color pattern is starting to become a bit more similar between the columns. You know, the order is not exactly the same, but the red ones tend to be at the top, and the blue ones, or the lower rank, tend to be towards the bottom. The one that's really not correlating all that well with the other ones is the eigenfactor score. So I decided to take that column out and re-rank everything. It's a much more regular pattern, but again, these metrics don't match up in a one-to-one basis. So it is important to take into account each of these metrics when you are evaluating a journal. But we can clearly see that there are certain journals that are in the high tier, journals that are in the mid tier, and journals that are in a lower tier. So I think that's a better way to rank journals than a fine scale saying, oh, Nature is better than Science because it has, an impact factor that is 1 or 2 higher. It's really hard to make that distinction without taking other factors into account. So again, the take-home message is don't rely entirely on journal impact factor. Don't rely on any single metric. So I hope you found this video interesting and informative. The metrics do correlate somewhat to each other, but not exactly. And so it's important to take into account multiple pieces of information when you're evaluating which journal you want to submit your paper to. Now, I made a previous video on how to decide on a target journal. I'll link that. If you got some value from this video, please hit the like button and consider subscribing to the Grants and Publications YouTube channel. I'll see you next time, and happy writing.